Okay, so now we're going to look at a more qualitative way to determine the acidity of a proton. We're going to look at the conjugate base stability. If the conjugate base is very stable, then the acid will be strong. So let's look at two examples. Here's hydrochloric acid. It's going to form a chloride ion. The chloride is a very electronegative atom, and it can stabilize the negative charge. It's electronegative, and it stabilizes the charge. And so that makes this strong acid. If we have butane, we end up with a negative charge, and we take off the proton. We end up with a negative charge on a carbon atom. And so the carbon is not very stable. The carbon can't stabilize the charge. And so this is a weak acid. So to compare two acids, we want to compare the stability of their conjugate bases. The more stable the conjugate base, the stronger the acid. And so you ask, how are we going to know how stable the conjugate base is? Well, there are four things we're going to look at. We're going to look at which atom is bearing the charge, what sort of resonance might be involved, induction, the effect of neighboring atoms, and the orbitals. So let's start by looking at the atom that's bearing the charge. If you're comparing two atoms and they're in the same row that's of the periodic table, the more electronegative one is more stable. And you remember that electronegativity increases as we go across our periodic table. If two atoms are in the same column, the larger one is more stable. Okay, so if something's in the same column, the one that's lower will be the more stable one. So let's see how this works in an example. Okay, so we're asked to determine whether the red or the blue hydrogen is more acidic. So what we need to do is, if we remove the red one, we get if we remove this, the negative charge ends up being on this carbon right here. It's extra electrons sit there. So what happens is something comes along and steals this, those electrons go there. So that's if the red one's removed. If the blue one is removed, we get those electrons go onto an oxygen. Well, carbon and oxygen are in the same row of the periodic table. Oxygen is the more electronegative, and so this one is going to be more stable. And if that one is more stable, then this is the more acidic hydrogen. It's easier to get rid of this hydrogen because the conjugate base that we make when we remove it is more stable. So we'll circle this one as more acidic. So let's compare the next ones. If we remove the red one, here we'll use some colors here. If we move the red one, we get something that looks like this. And we get electrons there, and we get a negative charge on the carbon. If we remove the blue one, we get extra electrons on the nitrogen and a negative charge there. Nitrogen is farther to the right and closer to fluorine, so it's more electronegative. It's better able to bear that charge, makes this more stable, and so this is the more acidic. You're more likely to be able to lose this one because the compound that it makes is more stable. Okay, so let's look at the last one here. If we lose the red one, we get, and we've got a sulfur there, and it's going to have a negative charge. If we lose the blue one, we get, and the oxygen gets the negative charge. Well, oxygen and sulfur are in the same column of the periodic table. Sulfur is a larger molecule, and it's better able to bear that charge because it has a more surface area, I guess you can think of. And so the sulfur is large, and so this is the more stable. So you're more likely to lose that hydrogen. It's more acidic. Okay? So that's how we can look at the atoms. We can also look at resonance. I told you when we studied resonance, resonance was going to come back and get us. And we're going to keep seeing resonance. Let me do